All right, let's work AP Precalculus homework 6-1. So I think what we really need to know about this is obviously SOHCAHTOA, sine, cosine, tangent, the definitions of secant, cosecant, and cotangent, and inverse trig and our special right triangles. That's what we need, so let's use them. Okay, so sine of theta, opposite over hypotenuse, right? And I think, maybe for just this one, I will write out, that's not what I was supposed to write, SOHCAHTOA. Okay, so sine is going to be the ratio of opposite to hypotenuse. Okay, opposite theta is going to be all the way across the triangle, so that's 3 over 5. Okay, cosine, adjacent over hypotenuse, is going to be the adjacent leg, that's 4, divided by the hypotenuse, which is 5. Okay, and then tangent is opposite over adjacent, so that will be 3 divided by 4. Okay, now what you need to know is that cosecant, secant, and cotangent are friends of sine, cosine, and tangent. They're the reciprocals. Okay, now secant and cosecant, those don't work the way you'd expect. Okay, what you need to know, I guess, is that cosecant of theta is 1 over sine theta. Secant theta is 1 over cosine. And cotangent is 1 over tangent. Okay, so cosecant theta, that's just going to be the reciprocal of sine. So if I've got 3 over 5 up here, this will be 5/3. Secant theta, 5/4. And cotangent, that'll be 4/3. Okay, on this next one, we've got an angle A. So instead of theta, we've got A, but otherwise no different. And I'm seeing 1/2 in root 3 over 2. Now, maybe we will need to be able to recognize this pattern in reverse. But if we see 1/2 root 3 over 2 and 1, that's a 30, 60, 90 triangle. Okay, now it doesn't matter because they're asking me about sine, cosine, tangent, cosecant, secant, and cotangent. But I am going to point out that I know that's the 30 because it's across from the 1/2, and the 1/2 is the short leg on a 30, 60, 90. And that means A is going to be 60 degrees. Okay, but other than that, that's all we're going to say about that. Okay, because, and actually I'm going to probably get that out of there, because sine of A, I need to be thinking from that perspective. Opposite over hypotenuse, root 3 over 2 divided by 1. Oh, divided by 1, that's really nice. Okay, we won't really be doing anything over there. Okay, so, whoops, I just want to get rid of the arrows. Okay, cosine is adjacent over hypotenuse, so I've got 1/2 divided by 1. That's 1/2. And then tangent of A, opposite over adjacent. Okay, so it'll be root 3 over 2 divided by 1/2. And I'll go over here. Root 3 over 2 divided by 1/2, well, I'm going to flip and multiply, times 2 over 1. Okay, that's equal to the square root of 3. And I guess I don't need to write it twice. So it's equal to the square root of 3. Right, cosecant. What I'm going to do, I'm just going to, flip these fractions. And, okay, secant will be the reciprocal of cosine, so that's 2 over 1. And then the rest of them, okay, I'm going to have to do a little bit of simplified radical form work, but that's probably exactly what you need right now. So 2 over square root of 3, we're going to multiply by root 3 over root 3, and so it's going to be 2 root 3 over 3. Okay, cotangent of A, okay, that's 1 over the tangent of A, and so I'll need to rationalize the denominator. So I'll get root 3 divided by 3. Now, sine B, cosine B, tangent B. This one's a 45, 45, 90 triangle. Same idea here. If the hypotenuse is 1, that's like best case scenario. So sine is opposite over hypotenuse. Opposite is dividing by 1. Okay, great. Root's just opposite. Root 2 over 2. Cosine of B, also going to be root 2 over 2. And tangent of B, okay, that's going to be opposite divided by adjacent. But those have the same length because it's 45, 45, 90. Or because you can see it's the same number. So I'm going to say tangent of B is going to equal 1 because anything divided by itself is going to be 1. I guess except for 0 divided by 0. That's not going to be equal to 1. Okay, so cosecant of B. I'm going to do this once, but I'm going to also point out that if you got like a really good, number sense about these radicals, that, you might could do this a little faster. So we're going to cosecant the reciprocal sign. So I'm going to say, all right, 2 divided by the square root of 2. And we're going to rationalize the denominator, but this is kind of going to be a waste. 2 root 2 over 2. Well, wait a second. That's just going to be the square root of 2. Now, if you heard what I said in the lesson or whatever, that root 2 over 2 and 1 over the square root of 2 and the square root of a half are all the same number, then you could have like kind of thought of it using that one and just flipped and gotten root 2 over 1. But I guess that does kind of just confirm what we had before. Cosecant of b is going to be the square root of 2. Secant of b, same thing's going to happen because I'm going to flip the same fraction, so I have no sense in doing that twice. Cotangent 1 over 1, that'll just be 1. Okay, now we're going to find the missing lengths of the special right triangle and find the trigonometric function of the angle. Okay, yeah, that's what it's saying. So we've got a 30, 60, 90 because we see it's a right triangle and one of them's 30. Okay, we've got x, y, and 8. So this is where we're going to need to bring out the template and then kind of work with that to scale it up. Okay, that's my 30, 60, 90 template. The hypotenuse is going to be 1, the short leg is a half, and the long leg is square root of 3 divided by 2. Okay, so I asked myself, what do I scale up the gray triangle by to get the black triangle? And that's just going to be multiplying by 8. Okay, so the 1 got multiplied by 8. As a result, the 1/2 will get multiplied by 8 and go to its corresponding side, which is going to be y. So y will be half of 8, which is 4. And then x is going to be square root of 3 divided by 2 times 8. So that'll be 4 square root of 3. Right. Now, sine of 30 degrees. Okay, I might as well just put these numbers in there. 4 root 3, 4, and 8. Perfect. All right, sine of 30 degrees is opposite over hypotenuse, 4 over 8. And that's going to equal 1/2. We do need to simplify that in this class. Cosine of 30, that's going to be 4 root 3 divided by 8. And that's root 3 over 2, which is the exact same thing. And I think that's kind of like the message here, is that if you notice, okay, that's the same 30-degree angle, we could do cosine of 30 with our template triangle. And that's what we're going to want to do in the long run. But for now, I think we're just kind of confirming that they're the same. If you think about sine and cosine of 30 on that template triangle, you're going to get 1/2 and root 3 over 2 with a little bit less work. Tangent of 30 is going to be 4 over 4 root 3. And that's kind of like 1 over the square root of 3, which I think I've already resolved in this video. That's going to be root 3 over 3. Yeah, that was up on the last page. Okay, then cosecant of 30 degrees. Okay, cosecant, that's 1 over sine. And I'll write that in there. 1 over the sine of 30 degrees. And we determined that the sine of 30 degrees was a half, so it'll be 1 divided by a half. That's 2 divided by 1. Okay, which I guess, I don't know about that. I'd be fine with 2 over 1. I'm just not sure about the free response section of the AP exam for this class. Okay, now we're going to have a 45, 45, 90 triangle. We've got x, y, and 4. So we're going to bring out a template triangle. And I really like it to have the same kind of like orientation as the triangle we're trying to scale up to. You don't have to do that if you don't want. I just think it makes it much easier, especially in the case of the 30, 60, 90. But anyway, if this is a 45, 45, 90, or my best effort at drawing one, I'm going to say, all right, the general kind of side lengths of a 45, 40, or the template one are 1, root 2 over 2, root 2 over 2. Okay, and so now I ask myself, okay, what did I just multiply root 2 over 2 by? Let's call it some number r to get 4. And then I'm going to solve for r by multiplying both sides by 2. So square root of 2 times r is going to be 8. And that means r equals 8 over the square root of 2. I will rationalize the denominator, and I'm going to get 8 root 2 over 2, and that's 4 root 2. Okay, so I need to multiply the 1 by 4 root 2 to get y. And then x, well, x is also going to be 4. Right? It's 45, 45, 90 triangle. We don't need to think too hard on that. Okay, so the sine of 45 degrees, okay, well, that's going to be, I guess maybe I should. Okay, sine of 45 degrees is 4 over 4 root 2. Okay, which, if I was going to simplify that, that's 1 over root 2. That's the square root of 2 over 2 number, that same number that keeps appearing with a 45, 45, 90. Okay, then cosine of 45 degrees, it's going to have the same effect because, you know, the side lengths are the same. Okay, so that's going to be root 2 over 2 again. Tangent of 45 is, okay, I need to remind you that you could think of this as sine theta divided by cosine theta. If we've just computed sine and cosine and they're the same, and we know that tangent of theta, or tangent of 45 degrees is sine of 45 degrees, but divided by cosine of 45 degrees, and then we could just kind of mentally divide them and be like, oh, you divide a number by itself, and you get 1. And then secant of 45 degrees, okay, probably remind you that that's 1 over the cosine of 45 degrees. Cosine of 45 degrees is root 2 over 2. Okay, once again, if I flip root 2 over 2, I'll have 2 over root 2. And that's just going to give me the square root of 2. Okay, there you go. Okay, moving on to the next page, I'm seeing a 30, 60, 90 triangle, so it looks like we're going to be doing the exact same thing. Let's copy in a template. Yeah, that looks usable. And so the 60-degree angle, that's across from the longer leg. Okay, the longer leg is root 3 divided by 2. The leg across from the shorter, or the smaller angle, the 30-degree angle, that's 1/2, and then the hypotenuse is 1. Okay, so that means that, what happened here to go from the gray to the black triangle? Oh, I like that. That's kind of nice. So we're going to go over here and say, all right, it's the root 3 over 2 that I can see the ratio on. So root 3 divided by 2 multiplied by some multiplier equals 1/2. Okay, well, r is going to equal 1 over the square root of 3. Because all I did was lose that square root of 3. And then I'm going to multiply, rationalize the denominator, and maybe you're like, dude, you've already done that in this video. And I've kind of decided I'm going to just go in and do it every time because I want you to be as confident with the mentally rationalizing the denominator as I am. And, you know, like, I'm fine. I just know that 1 over root 3 is the same as root 3 over 3. So I've done this a bunch of times. But I'm thinking maybe if we together do it a bunch of times that you'll see the same. So the multiplier is root 3 over 3. So I'm going to to get x, I'm going to take that 1/2, and I'm going to multiply it by root 3 over 3, and I'll get root 3 over 6. And then for y, I'm going to take that 1, okay, the thing that looks like the y there, and I'm going to multiply it by the multiplier, root 3 over 3, and if I multiply it by 1, I'm just going to get root 3 over 3. Okay. And so you can use whichever triangle you want, but these are both 60 degrees right here, so I'm going to use the reference triangle, the template triangle. Okay, eventually we're going to start calling it the reference triangle, and so I'm going to use that one, right? Sine opposite over hypotenuse. I like to do trig on a right triangle with a hypotenuse length 1, so I'm going to say sine of 60 is going to be root 3 over 2, opposite over hypotenuse. Cosine of 60 is adjacent over hypotenuse. That's 1 over 2 divided by 1. And then tangent is opposite divided by adjacent. So that I'm going to have to do a little bit of work on. Root 3 over 2 divided by 1/2 is like multiplying by 2 over 1. So I get root 3 over 1. Okay, cotangent of 60 degrees is going to equal 1 over the square root of 3, which I think we've done enough times at this point. We can confidently say that's root 3 over 3. All right, one more. Okay, I'm going to get the gray pen out. Draw a triangle that's probably not exactly 45, 45, 90, but it's all good, right? The hypotenuse is 1, and the legs are root 2 over 2. Okay, then I'm going to say, all right, what did I multiply the gray triangle by to get to the black triangle? I multiplied it by 12, so that means that x and y are both going to be root 2 over 2 multiplied by 12. So I divide the 12 by 2, and I get 6 square root of 2. Then, okay, sine of 45 degrees. Okay, we can use that one. Okay, that's really not, it's fine. You can see, obviously, if that's 45, then this one's going to be 45 as well. And that makes me feel a little bit better. That's the type of angle we're going to be taking sine on in the long run. Taking sine from the top of a triangle is not something we're going to be doing in this class. Not that there's anything invalid about it. It's just, I don't want anybody to get the wrong habit here. So, sine of 45 degrees is going to be root 2 over 2. Once again, didn't we already do this one? Cosine is also root 2 over 2. Tangent of 45 degrees is going to be 1 because sine and cosine are equal, or because opposite and adjacent have the same length. Cosecant of 45 degrees, that's 1 over the sine of 45 degrees. And that's going to be, all right, flip root 2 over 2. You get 2 over the square root of 2, and then we're going to rationalize the denominator. It's going to equal the square root of 2. Right, now doing some inverse trig. So write a formula for x that could be used to calculate the measure of the angle. Okay, so in case you didn't fully internalize the message in the lesson, I'm going to do all the steps, but if you did and you know what to do and you only need to write one line, go for it. You got this. I really think you can do it. So what I'm thinking here for the top left, I've got an adjacent and a hypotenuse, that's cosine. So I'm going to start off with cosine of x equals 9 over 12, and that's 3/4. Okay, now if I want to solve for x, I'm going to hit both sides of this equation with inverse cosine, or arc cosine, and maybe I'll use them interchangeably. I'll just kind of work, and maybe on the next one I'll do arc. So over here, the next one is going to be sine of x is equal to 9 over 12. That's, again, 3 over 4. Okay, and I don't know about that. I don't look very drawn to scale there, but it's okay. It doesn't matter. That's what I was saying in the lesson today. So I'm going to take the inverse sine of both sides, and I'm going to say x equals arc sine of 3/4. And then also, I'll know, I can look at the homeworks on, next time, and I can flip through them, and if I'm seeing, only inverse is on the left and arc sine is on the right, I'll know you're mindlessly copying, maybe even with the volume muted, and you don't want to do that, especially, for the next couple of weeks. Like I said in class, I'm just asking you kindly to be like a really good pre-cal student for the next couple of weeks, because it will pay dividends for the rest of the semester. Okay, next one. This one looks like sine also. 8 and 19, opposite over hypotenuse. Yeah, I'm going to say sine of x equals 8 over 19. So I'm going to take inverse sine of both sides, and I'll say x equals inverse sine of 8 over 19. And over here, tangent of x equals 11/12, opposite over adjacent. So x will be the arc whose tangent is 11 over 12. Okay, and I think that's going to be good. A formula for x that could be used to calculate the measure of an angle. Yeah, great. All right, now for these four. This is pretty much the same idea here, talking about forward and backward trig, but written in a very particular way that I believe might help you in the long run, or maybe in the medium term. Okay. So the figure below gives a right triangle where b is the length of a side and a is the reference angle. If the function f gives values of b as a function of a, write a formula for f of a. Okay. I highlighted it the same way, and I'm gonna do it just the same on this, same as I did on the notes on the homework. So when it says f gives values of b, we should be able to write a formula like b equals. And then the rest of the right side of that equation, that would be f of a, right? It would be a formula with a's in it, or maybe an a in it. And if the function g gives values of a as a function of b, write a formula for g of b. And so that'll be, a formula that shows us how to compute a if we know b. All right, so what I'm going to start with, like saying this triangle on the left here. What do I know? Okay, I've got an opposite and a hypotenuse, so I know sine. I'm going to say that sine of A is equal to B divided by 2. So that's going to be kind of where I'll start. Okay, I'm going to need to solve for B and solve for A. Personally, I think it's going to be a little easier to solve for B than to solve for A. So to solve for B, I just multiply both sides by 2. So B equals 2 times the sine of A. Okay. F gives values of b as a function of a, so that's going to be f of a. So f of a equals 2 times the sine of a. Okay. But if I wanted to solve for a, get at this on its own, okay, I'd need to take inverse sine of both sides, or arc sine of both sides. So I'm going to say, all right, a is equal to inverse sine. It's the angle whose sine is b over 2. And so then we could say, all right, well, that means f of b equals inverse sine of b divided by 2. Okay, over here, I'm going to have, this is going to be a tangent relationship. We've got an opposite and an adjacent. And I might need to make this pen a little thinner. So I'm going to say that tangent of A is equal to opposite over adjacent. So B divided by 4. Okay. And then I'm going to say, all right, if I want to solve for B, which maybe I do want to do that first, B is going to equal 4 tangent of A. And it told me that F was a function of A, so F of A equals 4 tangent of A. Okay, but if I wanted to solve for A on its own, I'd need to take inverse tangent of both sides. So that would be inverse tangent of B divided by 4, because inverse tangent of A is going to just give me A. That's the idea with a function and its inverse. They undo each other, they just kind of go away. All right, so G of B is equal to inverse tangent of B divided by 4. Oh, nice. I was hoping that we would get one like this. All right, so yeah, so I've got an adjacent and a hypotenuse. So I'm going to need to use cosine. Cosine A equals adjacent, that's the 1/2, divided by hypotenuse, that's B. And now I do need you to be aware that 1/2 divided by B is like 1/2 times 1 over B, so that this is equal to 1 over 2B. Okay, and the denominator. That fraction arithmetic is going to be like really important for us as we go through the trigonometry units of this course. I really can't overemphasize like all of that fraction number sense, how important that's going to be, because we're not going to use a calculator, and these are the places where you can go wrong and choose a wrong answer. So all right, cosine of A is 1 over 2B. Okay, that's not going to be all that helpful. What I'm going to suggest we do is think about it. No, actually, yeah, we'll just do this. Yeah, let's stick with it, and it's just going to have a few more steps involved. I'm not going to go into the secant world. That won't be necessary. Maybe I'll rewrite, maybe F in terms of secant. But first, I'm going to maybe rewrite this. Something's off here. So cosine of A equals 1 over 2B. Okay, so if I want to solve for A, I think that'll be easier in this one. I'm going to use arc cosine. So arc cosine of A, well, that'll just equal A. That'll equal arc cosine of 1 over 2B. Okay, and maybe I'll say, all right, that's G of B. Okay, but then if I'm trying to solve for b out of this equation, I do think that's going to be, yeah, in yellow. I'm trying to go for b equals. So I'm going to go and I'm going to start by multiplying both sides of the equation by 2b, because I think that's what y'all would think to do first. Me personally, I would want to flip both sides of the equation. I would want to say 2b equals 1 over cosine a, but I know a lot of students don't think to do that. So I'm going to say 2b times the cosine of a is equal to 1. And then I'm going to divide both sides by cosine of a. 2b equals 1 over cosine of a. And then I'm going to divide both sides by 2. So that's 1/2 times 1 over cosine of a. So it'll be 1 over 2 cosine of a. And, that would be a good solid formula for b in terms of a. So I could say f of a equals 1 over 2 cosine of a. But you could also say it's 1/2 of the secant of a, because a cosine in the denominator is like a secant in the numerator. Okay, so however you like it, right? Really doesn't matter. Yeah, and I'm just gonna stop on that one there. And all right, so for this one, I've got A and B and 8, and we're not assuming this is a 45, 45, 90, even though you know us. We've got a certain number of triangles that we're kind of like creating all of the art from for these units, and so that's why they're sometimes not drawn scales. We're just kind of using the same triangles over and over. So if I got A and B and 8, this is going to be a cosine again. How's this one any different? It's not a half. Okay, that's too bad. Okay. I'm missing no cosine of A equals 8 divided by B. So then, all right. You know what? I'm going to say B cosine of A equals 8. Equals 8. Yeah, I don't know what that was going to do. I guess I'm solving for B right now. So B equals 8 divided by cosine of A. So that's giving me a formula for A, that's F. Or, pardon me, gives me a formula for B as a function of A. Said that wrong a couple of times. That's unfortunate. 8 over cosine of A. We could also say that's 8 times the secant of A. Make sure that other one was also supposed to be a cosine. Yep, adjacent and hypotenuse. Okay, that's fine. And then if I wanted to solve for A, I'd probably want to use that equation, and I'd take inverse cosine of both sides. And so I'd say A equals inverse cosine of 8 divided by B. And so that would mean, kind of running out of room here, G of B equals inverse cosine of 8 over B. Okay, and there we go. Yeah, that's all of them. That's going to be all for this homework. So that's it for this video. Thanks for watching.